Hi everyone, we're going to go over a couple of those spring break questions that I required you to do from the EOC Do Now packets from the district. So we're going to take a look at the questions that are listed 13, 14, 17, 19, 25, 26, 37, 41, and 44. So get that packet handy and pause to read the questions because I'm going to go through them pretty quickly. Alright, let's take a look at the first one. We have number 13. So go ahead and read the question and I'll come back in just a second. Okay, so here the main part of this question is asking you for the difference between the volumes of the two pyramids. Now, when we're talking about the word difference, we know we're going to be subtracting. We're going to be subtracting the volume of the pyramid of Giza, which I'll use V of G, and then you're going to subtract the volume of the pyramid of Kukulkan. Now, you're not exactly sure which one is going to have the larger volume, but I'm just going to assume it's Giza for right now, and if that changes, I'm just going to switch which one I'm subtracting. All right, so since these are both pyramids, they have the same volume formula. Any pyramid, anything with a big point up top, an apex, like a cone or a pyramid, has the same volume formula. Let's take a look at our volume formula. Volume equals 1/3 big B H. Now that big B, I keep stressing it, it's not a number. It's the area of your base. So if it's a square pyramid, it's the area of the square platform. If it's an octagonal pyramid, it's the area of the octagon. So we need to take the area of your base, the big B, times the height of your pyramid, and then divide it by 3. Or multiply by 1/3. Now take a look at what they actually gave you. So in this problem, they gave you the height. You don't have to solve for it. And they also gave you the area of the base. They gave you the big B. You don't have to do any work except calculator work and plugging things in. So let's take a look at the first one. How are we going to find the volume of Giza? So according to our formula, we're going to multiply the big B, which is the 52,900, okay, times the height of 147, and then in the end we're going to multiply by 1/3. This is all going to be done in your calculator. So in my calculator, I'm going to go ahead. I'm going to do 52,900 times 147 for my height, divided by 3. So it's approximately 2,592,100 square meters. So I'm going to write that down as my answer for the volume of Giza. So it's going to be 2,592,100. Okay, and that is meters squared, square meters. Now I'm going to do the same thing for Kukulkan. All right, they gave me the height, they gave me the area of the base, and I'm just going to multiply those together and divide by 3. Okay, so if I lay it out, what I'm doing for Kukulkan, I'm doing the 1/3 times the 3,025, because that's my big B, times the height of 30. Okay, so in the calculator, 3,025 times 30. Okay, divide that by 3. All right, so my volume here is 30,250. All right, so I'm going to subtract 30,250 meters squared from the volume of Giza. So in my calculator, to do a quick shortcut, I'm just going to subtract the 2,592,100. All right, so it's a negative, but I know it's just going to end up being the positive version of this. So it's 2,561,850 as my answer. I'm taking a look at my choices. I'm remembering that they're asking me for the approximate difference. So it doesn't have to be exact. Now the closest one is obviously going to be choice B. So that's your answer. All right, so let's take a look at the next question. Okay, number 14. All right, read through number 14 again to familiarize yourselves, and then we'll come back. Okay, so now let's take a look at the question. Right now, the question asks you to follow through a bunch of different transformations to see which one will get this figure A, B, C, D to fall on top of E, F, G, H. Now, when you match these up, I've already matched them up. I've highlighted which coordinates, or rather which letters, map onto the ones from the new figure. So E, F, G, and H, those are all part of your new quadrilateral. This is a new one. And you're looking to see how A, B, C, and D matched onto E, F, G, and H. Now, A matches to E because they're both in the first place, B and F, C and G, and then D and H because of the position in which they are, the order in which they are listed. So what we're going to do to solve this question, we're going to go through each of our choices and we're going to see which of them gets your old figure, A, B, C, D, to map on top of your new figure, E, F, G, H. Now you only need to do one point at a time and see if it works. I'm going to start with A, and I'm going to see if A matches onto E with each of my choices. And remember, this one is a select all that applies, so it's very possible that we're going to get more than one answer. All right, so let's start with the first transformation. It says a translation of 3 units to the right, followed by a reflection across the x-axis. All right, so if I'm thinking about my coordinate plane, if my point's here, I'm going to flip it over the x-axis, so it's below the x-axis. All right, so let me go ahead and do that. So 3 units to the right, and then a reflection across the x-axis. Let me start with A, and let's see what happens. So A is here. I'm counting to the right. 1, 2, 3. So I'm right here. And then I'm going to be reflecting across the x-axis. So if this is my point, I'm counting down to the x-axis. 1, 2, 3, 4. Down 4 again. 1, 2, 3, 4. I'm going to end up right here for my new point A prime, which in this case is called E. That doesn't map onto anything for my new figure, so that's definitely not going to be one of my choices. So I'm going to erase what I just did to make a nice clean graph again. And I'm going to go down and I'm going to cross out choice A. Let's take a look at the next one. A rotation of 180 degrees. Now, if you remember the way that I teach you to take your paper, to turn it upside down and see what the new coordinate is. I'm not going to do that on the screen, so I'm just going to use the rule. It's going to be negative x, comma, negative y. Okay, so again, I'm going to work with A. A right now is at the coordinate negative 4, positive 4. So then if I'm going to rotate 180 degrees, let me take a look. I'm going to change the sign of both, so it's going to be 4, negative 4. And let me see if E is at 4, negative 4. 4, negative 4. Yep, E matches up. So far I think it's good, but I'm going to at least take another point to see if it'll work. Let's say with C. All right, C is at 1, 6. So then it should turn into negative 1, negative 6. Negative 1, negative 6. Yep, it seems to work. I would recommend going through all of your choices since you have unlimited time in the EOC, but I'm just going to go ahead and say, yes, this is going to work. All the points are going to match. All right, so in my choices, I'm going to say yes to the rotation of 180 degrees. Now let's take a look at the next one. Translation of 12 units downward, followed by a reflection across the y-axis. So if I'm reflecting across y, if my point is here, I'm counting to the y-axis and the same amount on the other side. So my point would reflect and look like that. All right, so moving downward, so I'm going y minus 12, and then I'm going to reflect across the y-axis. Okay, got it. Going up here, I'm going to erase what I have. All right, so again, I'm going to start with A. I'm going to go down 12. It's at 4 right now, so I'm going to go down 4. Now I'm at the x-axis. And then I'm going to go down another 8, so I'm at negative 8. All right, so this is down 12. Then I need to reflect across the y-axis. So I'm going to count to the right 4 boxes to get to the y-axis, then another 4 on the other side, and now I'm here. Nope, A does not match on to E, so that's not going to work. This is not the correct point. I don't even have to go through the other choices. C is not going to be my choice. D. a reflection across the y-axis followed by a reflection across the x-axis. All right, now these can be done in either order. You can reflect across x and then y. It's up to you. That's something that you'll notice as you start to do more of these, but let's just try this one out. So I'm taking A, reflecting across the x-axis and the y-axis. All right, I'm taking A. Let me just make sure which one it said to do first so I stay consistent. Okay, y-axis first. All right, taking A, I'm going to count to the right 4 and then 4 again so that I'm here. Then I'm going to count down 4 and down 4 again so I'm here. Okay, that one works. How about C? Reflect across the y-axis, so to the left 1, to the left 1 again, I'm here. Then down 6, and then down 6 again, I'm here. Okay, do that for all of them, and you're going to see that, yes, they do all match up. So this, again, is going to be a good answer, right? So I'm going to go ahead and also highlight that choice D is correct. And lastly, a reflection across the line with the equation y equals x. Now, this line, y equals x, we've studied it a couple of times. Y equals x, if I put it into mx plus b format, is x plus b. In this case, it would be y equals 1x, because there's an invisible 1 in front of the x value, plus 0. So what does this line look like? It looks like a line with a slope of 1 that passes through 0. So it looks like that. Now, if I'm reflecting over this line, I taught you to count diagonally. So if your point's here, count diagonally to your line of reflection, and then the same amount on the other side. But if you know the rule is you take your y and x values and they switch places. So it's x comma y becomes y comma x. Let's take a look at our visual and see if this will work. I'm going to erase what I have here. Okay. I'll try to do a nice straight line the best that I can. All right, so if I'm reflecting over this line with my trick of counting diagonally, I'm going to start with C because it's right here on the outside. C, I'm going to count diagonally 1, 2, and a half boxes. So I should count the same amount on the other side. Half, 1, 2. It's going to be a point right here. You know what? That's not going to work. And visually, I should be able to check and see that if I flipped it over this line, if I flipped my quadrilateral over that line, it's not going to end up where this bottom quadrilateral is. It just won't even look like it's going to be reflections of each other. So I'm going to say no, the last answer is also not correct. I did 1 point, it didn't work, it didn't match up with anything, so the whole thing is going to be off. So my only 2 choices I'm going to put here are B and D. All right, so take a look at the next video for some more questions.